All right, Math Counts people, we've got warm-up number 2 from the 2019 problem set. So problem number 41, here we go. So if the value of x is 10, what is the value of 3x plus 4x plus 5x? So combining like terms, we have 3, 4, 5 x's. So that's a total of 12 x's. And 12 times 10 is 120. Not too bad. That's just a speed problem right there. Number 42. In the figure, 2 regular pentagons have been attached to a regular hexagon. Okay, so we need some terminology there. Regular means that a shape has congruent sides and congruent angles. Congruent means they're the same measurement. So since both of these are regular, this is telling me that every single side is exactly the same measurement as we go around that shape. If each regular polygon has a side length of 3, that means all of these are 3's. What is the perimeter of the resulting 12gon? So I just need to find out how many sides are out here and then multiply by 3. So starting here, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've got 12 sides, so 12 times 3, the perimeter is 36. Next one, a speed of 60 miles per hour is equal to 88 feet per second. All right, so I've got 60 miles for every 1 hour is equal to 88 feet for every 1 second. All right, if the speed limit in a school zone is 15 miles per hour, what is the speed limit in the school zone in feet per second? Well, I do notice that 15 is 60 divided by 4. So if I want to change this one to 15 miles per hour, I would divide this side by 4 to get 15 miles per hour. And by the division property of equality, if I divide this side by 4, I should also divide this side by 4. So my answer, I don't have to do any crazy proportions or anything like that. I can just simply get my answer by, since I divided this side by 4, this side should also be divided by 4. So 88 divided by 4, 22 feet per second. How many divisors of 64 are perfect squares? So divisors of 64. Well, 64 is just a bunch of 2's being multiplied by each other. So we got to think of what are the perfect squares that are divisors of 64. So the perfect squares up to 64 are 1, 4, 9, 16, 25, 36, 49, and 64. So which one of those are divisors? 1's a divisor, 4's a divisor, 16's a divisor, and 64 is also a divisor. Don't forget about 1. You probably, if you wrote down 2 as an answer for this one when you first did it, you were probably only thinking about 4 and 16. But remember that 1 is also a divisor and the number itself is a divisor. And so 64 is 8 times 8, 16 is 4 times 4, this is 2 times 2, this is 1 times 1. So there are 4 different divisors there. So that one's like a simple problem that's easy to trip up on if you don't think through everything. Always think of 1 when you're thinking of divisors. A lot of people forget that. All right, next one. If A times B equals 2C, and B times D equals C, and B is not 0, and D is 16, what's the value of A? Oh dear, lots of this. Okay, so I'm going to just start substituting in here. So I know that D is 16, so I'm going to write that B, or 16B, is equal to C. Okay, so I've just plugged in 16 for D because they told me that they were equivalent. Now I've got 16 times B is equal to C, and now I'm going to substitute again. You can see I'm working backwards through this problem. I'm going to substitute into here. Instead of C, I'm going to plug in 16B because this equation says they're equivalent to each other. So I've got A times B equals 2 times 16B. Okay, I notice that I have B on both sides and everything's a factor, everything's being multiplied, so I want to get rid of those B's because I want to find A. So I'll just divide both sides by B. The b's reduce. And now we're left with a equals 2 times 16. A is 32. Next one, all the streets in Tom City are on a regular rectangular grid. They run east to west, north to south. Tom wants to start at an intersection of whatever avenue and 11th Street and walks 2 blocks east, so he goes this way 2, 3 blocks north, this way 3, then 4 blocks east, so he continues this way, then 5 blocks north. Make up your mind, goodness. Tom then returns to his starting location by going 6 west, which makes sense because 2 and 4 is 6. So he goes this direction 6, and then he goes 8 blocks south. That was a lot of walking for no purpose whatsoever. What is the area in square blocks enclosed by Tom's path? All right, well, there's a couple ways you can do it. The entire area here, if I count this section, would be 8 times 6, which is 48. And then I can subtract this section right here, which is 3 times 4. So the total area is 48 minus 12, which would be 36. You could have also like split it up right here and done 2 times 8 is 16, and then 5 times 4 is 20, and we still get 36 when we add up those two areas. Next. All right, this is fun. Lots of fractions. Okay, 1/2 plus 1/3 divided by 1/4 minus 1/5. Express your answer as a common fraction. That's an improper fraction that's been reduced. So let's start with the numerator. I need to combine these first. So the denominator would be 6, because that's the common denominator. So 1/2 would be 3/6, and 1/3 would be 2/3, 2/6. In the denominator, the common denominator would be 20. 1/4 is 5/20, 1/5 is 4/20. So in the numerator, I've got 5/6. In the denominator, I have 1/20. Okay, one thing that we can do when we have a fraction divided by another fraction, the denominators of the numerator and the denominator can move to the other side. So the 20 can move up to the numerator. The 6 can move down to the denominator. Now in the numerator, I have 5 times 20. So 5 times 20 is 100. In the denominator, I have 6 times 1, 6. 2 goes into both of those. 50/3 is my answer. There we go. The other way you could have solved this instead is turn it into a problem that looks like this. 5/6 divided by 1/20. And then like in 6th grade, you learned that like keep, change, flip thingy. So we would do like 5/6 times 2/1. And we're getting the same answer. Oh, that's 20, not 5. Sorry. It's like, why am I getting a different answer? This is 20, dummy. All right, so 5 times 20 is 100. 6 times 1 is 6, and we're getting the same answer. But this is kind of a quick way to do it. If you've got a fraction divided by another fraction, the denominator of the numerator moves down to the denominator. The denominator of the denominator moves up to the numerator. That's a quick way to do it. So either way, we get 50/30ths, or 50/3. Dang it. All right, moving on. What is the arithmetic mean? Arithmetic mean is the same thing as the average. We're going to add these numbers and then divide by the number of numbers, so we're going to divide that by 4. Okay, so I am looking at the denominators here, and I can see that I might want to combine these two first and combine these two second. So if I made these denominators of 9, this one would be 6/9, this one stays 7/9. So combining those two together, I get 13/9. If I combine these two and make them a denominator of 16, 1/4 is 4/16, and 5/16 stays the same. So I end up with 9/16. Now I need the common denominator. Hopefully you know that 9 times 16, which is 3 times 3 times 4 times 4, that's 144. All right, so at this point, I need to take 13 times 16. So 13 times 16 would be 208. I don't know. I think it's 208. Let me see. 13 times 16. 8, 1, 7, 1. Yeah, 208. I was right. That's 208. And then 9 times 9, 81. Now I can combine these two together, and I get 289 over 144. But we're looking for the average. These are all four of the numbers added together. So I would need to divide by 4. What we can do instead of dividing by 4 is multiplying by 1/4, and that would probably make it easier on ourselves. So if I multiply by 1/4, I can just take 144. 144 times 2 is 288. 288 times 2 would be 576. I think it out. Yeah, 576. And there's our answer. 289 over 576. Oh, that's delicious. All right. I remember no calculators on these, so doing things like this, where I split it up into 2 parts, made it a little bit easier than just finding a common denominator of 144 and then doing it that way. This was at least I think, a faster way to do it. Do it however you want. You guys think way faster than I do. So moving on. 49. All right, I'm gonna just be honest with you. I did this problem earlier, and at first I thought I was gonna be really smart. And I saw this, I was like, oh, I bet I can factor it, and then I can reduce stuff, and it's going to be great. And I ignored this part of the problem. This is super important over here, and it makes the problem really fast. Read everything. Don't get caught up and go, oh, I think I know what I need to do. I should start, factoring this to see if I can reduce. We don't need to factor this at all. Look at what it says over here. A plus B equals A minus B. And A is not equal to B. So how is this possible? How can we take A plus B and then take A and subtract B and have it be the same exact number? There's only one way this is possible. Did you think of it? B has to be 0. That's the only way that's possible. So now I can come back to this problem and go, okay, A squared times 0 is 0. That's 0. That's 0. The only thing left in the numerator is A. A minus 0 is still A. Oh, this is A divided by A, which is 1. Yeah, it's that easy. Sometimes we're too smart for our own good. Read everything. And sometimes things pop out like that to make it way easier. So this took me like 10 minutes to do this problem because I wasn't reading. So make sure you read everything and look for the shortcuts. There are usually shortcuts there. Last problem. Given that 75% of a certain number is 88, what is 3/8 of that number? Okay, so 75% is 3/4, right? So if we've got 3/4 of a number, x, that is equal to 88. Now you may be tempted to, at this point, multiply both sides by the reciprocal of 3/4. You're going to end up with a fraction, probably a pretty big number, and then you can take 3/8 of that. And that is totally fine to do, but it's the long way to do it. Let's look at what we have now. It's 3/8 of the number. 3/8 of the same number is equal to something over here. Do you see what's going on here? 3/4, 3/8. All they're doing over here is multiplying by 1/2. So if this side of the equation is multiplied by 1/2, all we have to do to get our answer is multiply this other side of the equation by 1/2 by the multiplication property of equality. If I multiply this side of the equation by 1/2, The other side of the equation will also be multiplied by 1/2. So half of 88, 44. We don't have to deal with tons of fractions. We just have to notice the relationships between 3/4 and 3/8. So answer, 44. All right, my people, that is all I got. Keep mathing hard. I'll see you next week. Bye-bye.